Hi, I'm Lindsay from StatsMedic, and in this lesson today, we are talking about significance tests for a proportion. We have two learning targets. We're going to state and check conditions, the random 10% and large counts conditions. And then we're going to calculate the standardized test statistic and then also a p-value for a significance test about a proportion. Okay, so our context today, I'm wondering, are you sure that I am not an 80% free throw shooter? So a couple of days ago, we used simulations to try to calculate the likelihood that an 80% free throw shooter shoots 64% or less. That's what I did when I shot my 50 free throws. Now the issue is when we did a simulation, all of my classes got different p-values. They got a different probability that occurs. So what I want to do today, instead of using a simulation, I want to use some formulas and some calculations. So number one, we're going to do together. These are just listing out our hypotheses again from that day. So let's see, we're going to start with our null hypothesis here. We had said was P equals 0.80. And that means in context, we said that Mrs. Gallus is an 80% free throw shooter. And then our alternative hypothesis was that I am less than an 80% free throw shooter. Okay, so we had already discussed those together. So now what I would like you to do is actually to work through the rest of this page. So the questions are going to guide you through some thinking about this. And instead of, again, estimating a p-value off of a simulation, by the time we get to the bottom of this page, we're going to have an exact p-value for the likelihood of this occurring. All right, so take some time to work through the rest of the page and then come back and we'll go through the answers and add in some formalization. All right, so when we start in question number 2, we are asked about whether it'd be appropriate to use a normal distribution to model the sampling distribution of p hat. So this is taking us back to previous chapters. So remember, when you're dealing with proportions, we're checking large counts. Now, originally, when we first started talking about large counts, remember we did n times p. The only time we did n times p hat was when we were dealing with a confidence interval because we didn't know what p was. Well, you might be thinking here as well, like, well, I don't really know what Mrs. Gallus's true free throw percentage is. But what we've done is we started by assuming the null hypothesis or assuming that I really am an 80% free throw shooter. So what I'd like you to do back up here on number 1 is next to this null, I'm going to write here is that we assumed the null hypothesis, which means anytime we need a value for p, we're going to use 0.80 because that's the assumed value. So for large counts here, one thing I do want to make sure you're noting is that you're doing n times p and not p hat. So I filled in 0.80 and 0.20 for both of those. Both are greater than or equal to 10. So I can use a normal distribution to model the sampling distribution of p hat. I'm going to write that in the margin as well. That again, we are checking large counts, and that is n times p and n times 1 minus p, both greater than or equal to 10. In B, we're asked if there's any other conditions we should check, and this is reminding us of confidence intervals, where we also have to check the random and the 10% condition. Random in this case, we're just going to assume that it's random, that I went to go shoot those 50 free throws. And then the 10% condition, 50 is less than 1/10 of all free throws shot by me ever. So what I'm going to do here by number 2 is I'm going to write, again, these are our conditions, and they're the same as they were for confidence intervals. We're checking large counts, the random condition, and the 10% condition. So we've got those 3 conditions again. All right, now on number 3, now that those conditions have been met, find the mean and standard deviation of the sampling distribution of p hat. So again, here I'm going back to that previous unit on sampling distributions. And I know that the mean of the sampling distribution of p hat equals p. And remember, we said since that has been assumed that p equals 80%, that's what I'm going to use anytime I am asked to use that, or anytime I need to use the value for p. So my mean for the sampling distribution is going to be 0.80. And then for my standard deviation, I filled that into my formula as well. And I get about 0.0566, 0.057, depending on your rounding. All right, now in number 4, we're using the mean and standard deviation to label the normal curve. So what I want to add on here, and maybe you didn't notice this, is you're supposed to fill in, so this is 0.80. And a reminder again, make sure you are labeling this with a capital N, mean, comma, standard deviation. And then in number 5, you are asked to turn that into a z-score. So going all the way back to unit 1 again, making this a z-score, we've got value minus mean over standard deviation. Now in this case, my value is going to be a p hat. Mean is p, the proportion that we've assumed, which is 80 or 0.80. And then standard deviation, I'm going to fill in that whole formula there. So I fill all that in and I get a z-score of negative 2.82. And then you could take that to table A or normal CDF and I get about 0.002. Okay, so what is that 0.002? That is my p-value. So if you could please write next to this on number 6, this again is the likelihood that an 80% free throw shooter shoots 64% or less. So less than a 1% chance of this occurring purely by chance. So on number 7, what conclusion can we make? Well, this p-value is very small. It is less than 0.05 or less than our cutoff of 5%. So we'd say we do have convincing evidence that Mrs. Gallus is less than an 80% free throw shooter. So again, when we did this in our simulation, everybody got different values. I think when we did this video for it, we got 2%. And really, it's actually even less than that. So when you're doing a simulation, your results are going to be a little different every time. When you're doing a p-value with a z-score, then you can find your exact p-value instead of an approximation. All right, let's look through our important ideas. So we had 2 learning targets. The first was about checking conditions. And those conditions are the same as they have been for a while. So that is, first of all, random, 10%. So the sample is less than 1/10 of the population. And then the normal condition, and when we are dealing with proportions, that's going to be large counts, which is n times p, and n times 1 minus p, both are greater than or equal to 10. All right, and then our second learning target was about calculating a standardized test statistic, which is really a z-score, and then calculating a p-value. So a standardized test statistic is a z-score. I'm going to put that in parentheses so don't forget. And p-value. All right, so in order to do that, we need to know what the sampling distribution is going to look like. Remember, when we are doing z-score calculations, I'm always looking for a picture, a z-score formula, z-score, and answer. So on this normal curve, what I'm going to label, this would be the sampling distribution of p hat. So mu of p hat and then sigma of p hat. And to the side, I'm going to note what those are. So remember, mu of p hat is equal to p, the true proportion. Now, in this case, we are assuming the true proportion, which is going to be based off of whatever our null hypothesis is. And then my standard deviation, sigma, the square root of p times 1 minus p all over n. Okay, so we'd figure out what those are. I'm going to go ahead and label in here. P is always going to be the mean, so that'll be right in the center. And then we need a z-score, or a standardized test statistic, which is going to be p hat minus p over square root of p times 1 minus p over n. And then we turn that into a p-value. So whatever you use for that, whether it's table A or normal CDF, you're going to take that from there. I do want to add in then that if our p-value is small, so p-value is less than 5%, then it is statistically significant. And we have convincing evidence. And really what we have convincing evidence for is the alternative. And we're going to talk about that more in tomorrow's lesson. We'll get a little bit more formal with that interpretation and conclusion at the end, but I did want to add that in here for now. All right, so if you could take a few minutes and work through the check your understanding problem and then hit play when you're ready and we'll go through the answers. All right, so starting in part A, we are asked to state our hypotheses, and they do remind us as well that we want to be sure to define our parameter. If you define your parameter like this, where you've got P, the true proportion of students who can identify the smell of a skunk. So then when you go to write your hypotheses, you don't have to write them in context. You can just use the symbols. So my null is that P equals 0.90. And then the alternative, they mentioned up above that we are looking at trying to decide if we have convincing evidence that less than 90% of students can identify the smell. So I did less than on that. B, why do we have some evidence? Well, from her sample, 84 out of 100 could identify the smell. Well, 84 out of 100 is 84%. That's less than 90%. So I at least have some evidence because I am below 90%. C, we're checking conditions. The big thing here is just making sure that when you're checking the normal condition, make sure you are using P and not P hat. D, calculate standardized test statistic and p-value. All right, so again, a reminder here, I am always looking for a picture, z-score formula, z-score, and then final answer, which now we know is a p-value. So I've got here my picture, make sure it is labeled correctly, my z-score formula, z-score, and then p-value from either table A or normal CDF. And then lastly, what conclusion can we make? Well, my p-value is below 5%. So because 0.0228 is less than 0.05, we do have convincing evidence that less than 90% of students can identify this smell. All right, so as mentioned in the next lesson, we're going to look into significance tests for proportions a little more and get even a little bit more formal and how you need to write this up exactly and formatting we'll be using.